Welcome back to part 2 of the theory of plate tectonics. In part 2, we will cover 4 main objectives: oceanic crust, mid-ocean ridges, continental crust, and subduction zones. Oceanic crust is mainly composed of basalt rocks. Geologists refer to the rocks of the oceanic crust as SEMA. SEMA stands for silicate and magnesium, the most abundant minerals in the oceanic crust. Basalts are SEMA rocks. Due to the rock composition, oceanic crust is more dense than continental crust. Density is the measure of mass per volume. The average density of an object equals its total mass divided by its total volume. Oceanic crust is constantly formed at mid-ocean ridges, where tectonic plates are diverging. A mid-ocean ridge is an underwater mountain range. This uplifting of the ocean floor occurs when convection currents rise in the mantle beneath the ocean crust and create magma where these two plates diverge. As the magma seeps through the separating plates, becoming lava and rapidly cooling, creating new oceanic crust. In this image, can you spot the mid-ocean ridge? Continental crust, mainly composed of different types of granite. Geologists refer to the rocks of the continental crust as CL. CL stands for silicate and aluminum, the most abundant minerals in the continental crust. CL can be much thicker than SEMA, but slightly less dense. Let's compare the two different types of crust. Oceanic crust is younger than continental crust. Oceanic crust is made of basalt, whereas continental is made of granite. SEMA and CL are the most abundant minerals. Oceanic crust is more dense and thinner. Continental crust is less dense and thicker. Thinking of these comparisons, what do you think would happen when a continental and oceanic plate collide with each other? As oceanic crust is denser than continental crust, it sits below continental crust. When these two plates collide, the oceanic plate is subducted underneath the continental plate. The oceanic crust is recycled back into the mantle. The phenomenon of subduction causes oceanic crust to be much younger than continental crust. Continental crust is always much older than oceanic crust because it is rarely destroyed and recycled in the process of subduction. Some continental crusts are nearly as old as the Earth itself. Thanks for watching.